Welcome to Modbus course. During this course, you will gain a comprehensive understanding of how to use the existing Modbus interface. Let's take a look at the course roadmap. First, we will dive into the basics of Modbus, then we'll focus on gathering data for the interface. We'll look at the datasheet and identify what's important and what's not, then how to get the interface and how to deploy it. Then we will prepare the program for use. That means we'll change some settings so the program and the device in the field match each other, and afterwards we'll conduct tests to confirm its functionality. Modbus is a data communication protocol, and within the Fidelix system we have Modbus TCP, which is used over the Ethernet, and Modbus RTU, which is the serial version of Modbus. Modbus is a client-server protocol. Previously used to be master and slave. It changed a while ago. Master, usually the controller, is now referred to as the client, and slave, usually the field device, as the server. There are 4 types of registers in Modbus. One of the most commonly used is coils, which is a 1-bit read-write register. It is used for controlling off points and reading alarms or indications. Then we have discrete inputs, which is a 1-bit register, but read-only. It is used to read indications and alarms and other 1-bit like on-off data. Then we have the input registers, which are 16-bit read-only registers. These are primarily used to read various measurement values. And then we have holding registers, which are 16-bit read-write registers. Holding registers can be used to all the same functions as the other 3 register. For read-only thing, you just need to not write the register. The holding register is the most used register in the Modbus system. Moving on to Modbus function codes, these are used to access the registers. For the discrete inputs, we have function code 02. For the coils, we have function codes 01, 05, and 15. For the input register, we have 04, and for holding register, we have 03, 06, and 16. All these function codes perform different actions. Some devices could be made in a way that they don't support all of the function codes. Usually both write single or multiple registers function codes are not supported. That means there could be devices that only support writing single register, but not the write multiple registers function code. Keep this in mind. Modbus RTU is wired as a serial bus. At the start point, we have many options. Example, multilink or RS485C. On the start point, there is data A- and data B+ connectors for the bus. It's crucial to ensure that the ground level matches between the device, the start point, especially when field device has its own power supply. Also, the wiring needs to be serial bus. No branches or star connections allowed. The cable must be shielded, and the shielding must be continuous through the cabling. The shield is connected to the ground only at the starting point. Here we have a 120 ohm termination resistor, which will be connected to data A and data B. Its job is to stabilize the bus voltage. Modbus TCP uses basic Ethernet cabling and connects directly to the CPU in our system. Now let's look into a few Modbus settings. Modbus TCP has basic IP settings. Because Modbus TCP is used in small and big devices, you need to know if you're connecting straight to the device or by gateway. In case there is gateway, you might need unit identifier to access the device you want. Then we have Modbus RTU, which has a Modbus address. It can range between 1 and 255. Then we have different bus speeds, parity, data bits, and stop bits at the end. So all of these settings need to be matching between the device and the controller. Only unique setting is the address of the server device. Thanks for watching. See you in the next video.